Hello and welcome. I'm Hullhound and today we'll be continuing to make our Frogger clone using Godot 4. If you haven't already, I recommend starting from part 1. In our last video, we implemented water, drowning and platforms. In this video, we'll be completing the water section and all the obstacles and platforms that we'll be using. In the last video, we added in water platforms. These platforms prevent the player from drowning. Each of the platforms are 1 tile long. So if we want to have a longer platform, we need to use multiple platforms to build up a large platform. Alternatively, we can write some code that makes the platform longer, depending on what length we determine the platform should be. That's what we'll start with. In our platform, we have a number of different nodes that are impacted depending on how long our platform is. The main ones being Sprite 2D, which is what we visually see when we're looking at the platform. The Area 2D, which is our detection for whether or not a player is safe from drowning. And then the Player Mover 2D, which actually moves the player when we're standing on the platform. The visibility offset is also somewhat related, but we can also trick our way around that if need be. Now that we've identified the nodes that we need to duplicate, we can start by separating them out and identifying how we will duplicate each particular thing. So the ones that I'm going to focus on first is the Sprite 2D node and the Collision Shape 2D node. It's worth noting that for an Area 2D, it's the collision shape that determines whether or not a collision is registered, and because we're connected to the area entered event, that means that we can have multiple collision shapes, and if the player is interacting with or colliding with more than one of them, then we'll still only get one event, which is what we want in this particular circumstance. So let's separate the Sprite 2D and the Collision Shape 2D into a template object. For our purposes, this can just be a node 2D that we rename templates. I can just drag in Sprite 2D and the Collision Shape 2D. So we will get an error or a warning on the Area 2D because it doesn't have a shape. We'll fix this by making sure that by the time the actual game starts, we do have those shapes. So let's start by creating the function that will move the element in the templates node into the Area 2D node. So I'm just going to call this setup length. And all I'm going to do is drag in the Sprite 2D and the Collision Shape 2D. That gets the path. So here I can say Sprite is this, and shape is this. And for convenience, I'm just going to mark these as a Sprite 2D and a Collision Shape 2D. And then all I'll do is, for the purpose of the moment, area 2d.addChild sprite and area 2d.addChild shape. If I call this when we are on ready, then there's very little functional difference between what we had before and what we have now. What I forgot to do there was to duplicate the nodes. So because these nodes already have a parent, when we try to assign them to area 2D as a child, they're erroring because they already have a parent and you can only have one parent. So either I would need to remove the parent first and then assign them, or because it's what we're going to need to do anyway, we will duplicate the shapes and the sprite. If I hide the template so that we only have the one, when I press F5, we will now see that we're working. You'll notice I've turned on debug collision shapes here, which is quite a useful tool for if you're trying to identify why something isn't working, you can use that from debug, visible collision shapes. If I turn that off, we'll now have the game as it was. Now that we can duplicate what we already have, let's make it so that we can control the length of this. So what I'm going to do is I'm going to create a loop. So in Godot, that's 4. In this case, I'm just going to call item, and then in, because I want effectively iteration over a set of numbers, I can say range, brackets, between 1 and length. For the purpose of the moment, I'm just going to say 3. But it's worth noting that range is inclusive on the left, exclusive on the right. So if I wanted to have something of length 3, it actually needs to say 4. Optionally, I can go up by a different set of numbers by adding a comma and then a iteration amount. I'll just leave that as default, which is 1. If I do this here and then just tab that in so that the for loop knows what it's relating to, we will now add in multiple of these copies of the sprite and the shape. But as it stands, they'll just be overlapping each other, meaning there's no functional difference. So let's adjust that slightly by adding in an export variable called tile offset amount, and we'll call it vector2, and we'll start it off with a value of 16 and 0. That's our default. So now what we can do is we can say sprite.position equals our item times our tile offset amount. That's just -1 because we want our item to be 0 offset when we're at 0. And I can duplicate that line and use shape. So now, if I run the game, I would expect to see a longer platform. However, if I go onto it, I'll move along, but not move at the point where I enter, which is not what we want. Before we resolve the issue with the player movement, let's touch up the code that we're using to actually display the longer platforms. At the moment, we're having to do it in code and having to have a manually set value. Let's change that. Let's add a export underscore range. So an export range tells Godot that this is a number between two numbers. And it can then use that in the inspector to actually make it a little bit easier for us to enter values. So in this case, I'm just going to call this length and say it's an integer. I'm going to get a default value of 1. So there, we'll just let that compile. I do need to say between 1 and 5, or whatever length I want to allow. If I then go to the level, select the platform, I now have a number box that will only go between the values of 1 and 5. Now that we have that, we can use this length in our range, say +1, because remember they're exclusive on the right. And we're now able to do what we did before. So going to 2D, on length we can make it 5, press F5, and we now have a longer platform. Unlike our vehicles, we're not able to see the length of the platform before we actually start playing the game. So let's change that in much the same way that we did with the vehicles so that we can see that. We go back to our safe platform, at our code, we can add the @tool directive, which then means that this script will also run in the editor itself rather than just the game view. What that does mean is we need a slight adjustment to some of our code. So if we were to go to the level, press 2D, we can see that we have our code running, but trying to change the value doesn't do anything. So in the first instance, let's change our code so that before it tries to do anything, the first thing that it does is clear what's already there. So make another for loop for child in this case area 2D. So what we want to do is get its children, and then for all of its children we just need to call Q3, which is delete effectively, but deleting it at the end of the frame rather than immediately, which is normally what you want to do for performance reasons. So we run that now, we have what we needed, but in our inspector, if we change our values, again, nothing happens. And that's because we're only updating the length when we're calling the onReady, which happens when we play the game. What we instead need to do is use a setter. So what we can do here is set, actually, do another line, set brackets value, and then we can now run code when a user changes the value of length. So in this case, I'm going to cheat a bit and have a inner length. You can call it whatever you like. I'm going to default to 1. All I'm going to do here is set inner length to be value, and then call setup length. And for completeness, we also need a getter. And all that means is whenever we try and check the value of length, we run this code. And it's from a getter you always have to return. It's normally good to return whatever you've just updated when you're doing it using this pan. So what we have here is the set get pattern. So whenever we change either set or get the value of length, then we run either the set code or the get code, depending on what we're trying to do. These are useful in a wide variety of situations. For the purpose of this, it allows us to have the inspector update the element that we're seeing in real time. So now if I go to level, I can now update length, and we see that our thing is getting longer or shorter as we need it. What we can see, however, is that our collision shapes do not match where our sprites are. So let's investigate to why that is. Take a moment to try and identify why our collision shapes are offset compared to our sprites. Feel free to pause the video and explore what we currently have before you continue. I'll assume you're back now. The reason we have an issue is that if we look into our safe platform, we can see that our sprite 2D has its default transform, whereas our collision shape 2D already has an offset. And that's to do with the fact of where our sprite 2D starts, which is the origin is at the top left, whereas our collision shape 2D has its origin in the center. What we instead need to do in our code is change it so that our shape dot position is plus equals the tile offset amount. If we then go back to the level, what you should now see is that they now match up. At this point, we're ready to fix our player movement code for when our player is on a platform. The issue that we have before is even clearer now that we have a longer platform. For example, if I stand on here, we can see that I keep moving until I'm towards the end of the platform. This is because our player mover 2D is only on the last tile and not on the rest. So although we're safe, we're not moving. Inside the player mover 2D script, we have our area 2D called player detector and its collision shape. what we need to do is add multiple collision shapes to match the length of our platform. Because this is a self-contained node, we need to add functions to allow us to manipulate this. So the ones that we really care about is clearing the list of collision shapes and then adding a collision shape. So we can add those functions quite easily. So what we need to do is create a for loop to go through the collision shape to the player detector. Specifically, it's children in this case. And then we'll mark it as Q3, free, as we have done previously. Equally, we want to add a collision shape. Which we can do nice and straightforwardly using the add child. So that's the actual functions that we need for the player to move a 2D script. Within our safe platform, we can call these. So I'm just going to copy and paste because I like to be lazy where I can. And then here I need to do much the same. Move 2D.add. Let's copy and paste again. Add collision shape. In this case, shape.duplicate. And now, if we press F5, we get an error message. Okay, so here we're having a situation where, because we're assigning it, we're calling the setup length, but we've not necessarily got everything that we need because area 2D hasn't been created. So it's useful to create a little guard clause here. Area 2D equals null, then return. And that just neatly avoids that issue. And we now have our movement script. Now that we have our safe platform fully complete, what we can do to add a bit of additional challenge is to make a platform that is sometimes safe and sometimes isn't. And that allows a user or a player to have to time when they step onto the platform and when they move off it. Let's get started. So to begin with, let's duplicate our safe platform. In this case, I'm just going to mark duplicate. I'm just going to call it unsafe platform. Going into here, we have a duplicate of what we already had. It's a bit clear, I will rename this. There are two components that we're going to need to use in order to make these platforms unsafe. One is actually making the platform unsafe, and the other one is visually telling the user when a platform is about to be unsafe and when it isn't safe. So to help guide us with this, we have a node called an animation player. An animation player is a node that helps manage changes. So it allows you to have a set amount of changes over a time frame. It's a very, very useful node that you can use in a lot of different ways. I'm going to call this unsafe cycle. That's just the name of the animation. So what we have in the animation player is an animation track. And what that means is it's a set of actions that will happen whenever we play an animation. In this case, I want this to cycle and I want it to auto start. So I'm just going to press here, which is auto start, and here, which is to repeat. What I'll do is I will now start building up what we need. So in this case, I'm going to set area 2D. I'm going to go to visibility, and modulate is what I'm interested in. So to begin with, I'm just going to click the little key, and then press create. So what this does is it adds a keyframe for this property within my animation. What that means is if I currently play it, nothing will change. If I set my animation so that over here, actually do the middle first, I change my modulation to magenta-ish, and then do keyframe, and then back to here, set this to reset, add a new keyframe. If I place one of these into my level, because remember we haven't done this yet, because this is an unsafe platform. And just to add a bit of distinction, I'm just going to 16. Apologies, wrong line. That way. If I F5 it, we can see we have our visuals going between standard and purple. So what we want to do to make this a bit easier for our player is to cycle the colours in progressively more aggressive colours, for lack of a better term. So give that a crack yourself, and I'll show you what I do in a moment. As a quick note, you can adjust the length of the animation by changing the property here. So in this case, I've changed mine to 3 seconds. Welcome back. So this is what I eventually settled with. A length of 6 seconds and a progression of shorter and shorter orange flashes followed by a long red flash. Did you get something similar, or did you do something different? One of the things that I've done here is I've used the sort of white, the clear, between my blocks of colour. What I could also have done is adjust the easing, but we'll leave that for a separate video. This is just a simpler way to get sharper edges. We now have it visually working with the game, and we can see that the flashing is happening on the unsafe platform. However, it isn't actually doing anything to make it unsafe. So to avoid this, or resolve this, we can do something very similar to what we've already done. Say we've done the area 2D in the animation player. Let's do it again. So the property we want to be modifying is the process mode. So here we have the option of when this node runs effectively. So by default, you always base it off your parent, which is inherit. But you can also select when something should only run when it's pausable, when paused, should always run, or it shouldn't. So in our situation, at the point when we go red, we need to change this to be disabled. And then when we become unread, we want to change it back to inherit. What I like to do is at the beginning and the end, mark it back at whatever your default is, just to make sure that it's as you expect it to be. Now, if we run, and then cinematically wait, so we can get to the unsafe platform, what we should find is that when it goes red, it now kills the player, which it does. Excellent. That works because what we're doing is we're saying turn off this area 2D, and it's the area 2D that is keeping our player safe. But because we're turning it off, the physics engine says, okay, well, we'll remove this from the physics system, and therefore when we're checking whether or not a platform is underneath us, the system is returning no, a platform is not beneath us, and therefore we're colliding with the water and therefore dying. At this point, we have all the components needed in order to flash out our level. So what we need to do is create the level. We'll do this as an exercise. So what I'm going to do is I'm going to create a layer of unsafe platforms next to the player, 2 layers of safe platforms, a layer of unsafe platform, and then a final layer of safe platforms with a vehicle in front of it, such as a helicopter, just to make things a bit spicier. That'll leave us one row at the top, which we'll use for our goals, which we'll touch on in the next video. So as an exercise, just make your own level layout, and I'll show you what I do in a moment. So this is what I eventually settled on. It's a bit difficult, but nonetheless, here we are. What you may also notice is that the longer platforms, when they go off the edge, are correctly coming in on the other side, instead of like popping into existence. And that's particularly important in one direction rather than the other. And the simple little workaround to make that work is for the tile offset for your platform, you can select it as -16. And because the visibility is always then on the end, it means that it will only run once it's fully invisible from that end. There's a little trick to save us having to make any further code adjustments. What that means mechanically is that by having a -16 offset rather than a 16 offset, it builds the length in the opposite direction. That's it for this video. Remember to subscribe to be notified when part 6 comes out.